Hello class and welcome to Bitumen and Asphalt. This will be your final material that you're covering in building and materials and testing. Isn't that exciting? So what journey we've been on? We've looked at aggregates, we've looked at cements, we did an introduction to concrete, we've looked at masonry, we've looked at wood and wood products, and now we're finishing off with bitumen and asphalt. Because of the shortened nature of this semester, we will not have time to go into steel and aluminium and glass and ceramics as I had originally hoped for. But don't worry, if you can easily read those chapters in the Civil Engineering Materials textbook if you're interested. Now, I do need to let you know that you have assignment 6, that is due on the 21st of June, and that covers wood and wood products. So this should be your second lecture in week 8. The final lecture of wood and wood products would be the first lecture of week 8, and your assignment for wood and wood products is due next Sunday, 12 p.m. 21st of June. There will not be an assignment for bitumen and asphalt. Basically, this is going to go right into our final week, and I don't want to overload you in the final week with assessment, especially because many of you, or all of you, or most of you are doing six modules this semester. So bitumen and asphalt, this will be solely covered in the online examination that we will be doing in week 10 and 11. So keep that in mind. One other thing I should point out before going to the first slide is asphalt. You may have heard it pronounced asphalt or bitumen. That's pronounced bitumen. Well, it depends if you're American or English or British. I'm a New Zealander, so we sometimes pronounce things with the American English, sometimes with the British English. With these two words, I have a tendency to pronounce them the British way, so I say bitumen and asphalt. You can pronounce it whatever way you want, I don't care. So, in this section, we're going to be learning a little bit about the history of bitumen and as it's used in civil engineering. We're also going to be talking about key properties of asphalt, and with that is, what is the difference between bitumen and asphalt? Are they the same thing? We're going to be talking about different kinds of asphalts and their advantages and disadvantages, and how they apply to civil engineering. We're not necessarily going to do that in order, but hey, that's more or less the pattern we've followed with all of the materials thus far. So before we continue, I just need to give you a little bit of a vocabulary lesson here. Bitumen. What is bitumen? Well, when you pump oil out of the ground, bitumen is the most viscous, sticky, thick oil that comes out of the ground. It's the lowest quality oil. That's what you can't use it for making fuel. It will just clog up the pipelines. It's very thick and gooey. It's sort of often got a texture of peanut butter when it comes out of the ground. That's bitumen. I'm sure you've all seen it, and it's very black and very dark. Now, asphalt, that is a mixture of bitumen with aggregate. So you've got to remember the difference between asphalt and bitumen here. So it's a little bit like concrete. Remember, concrete is distinct from cement. Concrete is a mixture of cement with aggregate, and asphalt is actually a mixture of bitumen with aggregate, and that's why historically it has actually been referred to as asphalt concrete. These days we just say asphalt. Now, tar. What's tar? Tar is a type of bitumen, but it's a special kind of bitumen. It's not bitumen that has come out of the ground from oil. It's not the lowest quality oil that with very long hydrocarbon links that you would get at an oil field. Instead, tar is basically what you get when you burn and then you distill coal and plastics. So if you can imagine the burning coal and burning plastic, what do you get? You get this really dark, black, sooty smoke that comes out. And then if you were actually going to condense that, you're going to get these big black raindrops coming out. And that is tar. So it's a way of getting bitumen where you don't have oil. It's a way that you can get it from basically burning coal or burning plastics. Now pitch. What's pitch? Well, pitch is basically a tar that is solid or semi-solid at room temperature. It's not liquid. So basically you need to heat pitch up in order to get tar as a liquid element. So yeah, tar is quite distinct from other bitumens. But this is where it gets a little bit confusing. What's a tar-sealed road? Well, it's basically a road that has an asphalt wearing course. Many years back in the 1910s, 1920s, that asphalt would have been aggregate mixed with tar. And so that's why we call the road a tar-sealed road. These days, we never use tar for roads anymore. We use hydrocarbon bitumen. So bitumen that has come from the oil field, we mix that with aggregate and then we make an asphalt and that goes on the road. But the name tar-sealed road still remains. We still use that term. So this is a picture right there of pitch. So pitch, it looks a lot like coal, doesn't it? But you've got to remember, you can't actually burn pitch. If you were going to heat pitch up, it would melt, and it would melt into tar. So it's basically the distilled remains from burning coal. So if you burn coal, it creates that big, thick, black smoke. And if you condense it, basically you cool the smoke down, it's going to form these big black raindrops or condensation. And that's tar. When it dries and it cools to room temperature, it forms pitch. Now, one thing you should know about tar is it's quite brittle compared to petroleum bitumen. What do I mean by brittle? Well, it means that it can actually break and snap quite easily. Now that's quite important. If you were using tar as in a tar-sealed road rather than bitumen in your asphalt, that will mean that the black stuff, the tar, would crack and break a lot easier than if it was bitumen. And that's why tar-sealed roads, they had a tendency to get a lot of potholes forming in the road. But basically, and that's why they switched to bitumen when they could. But there are a lot of potholes in Kurdistan. We'll talk about that later. But it's not because they're using tar. They're using bitumen. But why did we used to use tar? Well, I have to say, I don't know if they ever used it in Kurdistan, but it was very common in the US, very common in Europe, and also very common in New Zealand and Australia, and in many parts of Asia as well. Why was that? Well, it was because we didn't have any oil. We had to import our oil from Kurdistan and Bahrain and from Saudi Arabia and Iran, and we still do that. Not Iran, of course, but the other countries we do. And so we didn't have a good source of bitumen. What we did have a good source of was coal. There's a lot of coal in Europe and in Australia and New Zealand, and we used to burn coal to make electricity. And basically the waste smoke, we could use that to make tar. And so it was basically a waste product of the electricity industry, tar, and we could use it on our roads. Now these days, there's a lot less coal combustion happening for electricity generation than there used to be. Basically, the world's running out of coal. Countries are moving to other energy generation facilities such as oil generation, gas generation for generating electricity, or renewable energies. So in New Zealand, they had one coal-powered station in the entire country. They shut that down about 7 years ago. It's closed now. There's no more coal being combusted in New Zealand. So that's why tar is basically being forgotten, slowly but surely. There is one place tar is still being used, though, instead of petroleum bitumen. What is that? Well, it's used for waterproof paints. This is tar is uh, gets a little bit harder than bitumen, and you can also make it runnier than bitumen, so it has less viscosity. And so what this man there is doing, he's painting a foundation basement wall with a type of tar paint. That's why it's that black color. Why is he doing that? Well, bitumen and tar and all hydrocarbon products, like all oils, they're waterproof. This is going to stop water getting into the basement by painting it with this waterproof paint. So this is actually another house. This was a house being built close to where my in-laws live in Philadelphia in the USA. And you can see they've built a big solid platform there to build a house. But they've painted around the edge there with this black tar paint. And that's to keep it waterproof. That's to stop water getting into the low quality concrete and potentially damaging the foundation over time. So it's creating a waterproof barrier. They could really do... Guys, this is actually something that you really need to start doing a bit more of when you build houses in Kurdistan. Often you're not painting the parts of the house that are buried underground, and that creates issues with water getting in under the house and then through the house. That's why houses in Kurdistan, one of the reasons why they're so damp. The other reason is that you're using breeze blocks, which we talked about in masonry. So tar, that was used a while back, but basically since the 1950s until now, basically tar is not being used very often now. It's being used for paints, but other than that, it's not really used for much at all. The reason for that is because we have a really big global petroleum industry. That's the bread and butter of Kurdistan, is basically exporting oil to the rest of the world. It's by far your biggest export. But obviously, what you need to know is when you get oil out of the ground, you have lots of different qualities of oil. And it all has to do with the length of the hydrocarbon. So oil is a hydrocarbon. It's a big chain of carbon molecules in a big chain, and they are surrounded by hydrogen atoms. Now, the longer the chain, that will mean that it's going to be thick and viscous and lower quality, and the shorter the chain, the cleaner burning it will be, and the more runny and even the more gaseous it will be. And so when you actually refine oil, you need to separate all of the different kinds of hydrocarbon out into their different groups. And the way you do this is using fractional distilling. So what's fractional distilling? Well, basically you take the big oil and I don't know if you can see my cursor, probably not. But if you look at that picture on the right, you can see on the left of that picture, you're putting the crude oil, the oil that you got out of the ground, through a really big furnace. And you're heating it up very hot. And then, and you'll be heating it up to, probably around 200 degrees Celsius. That sort of temperature, I believe. Now, about 400. Oh, sorry, I'm being told here by Google it's actually about 600 degrees Celsius. So they heat it up to 600 degrees Celsius. That's why I'm a civil engineer, not a petroleum engineer. Now, when they heat that oil up, they heat it up slowly so it doesn't explode and catch fire. But they basically heat it up slowly and it basically turns to a gas. And then that gas goes into this really long column called a fractionating column. And what happens is that the gases, the hydrocarbons that have a really short carbon chain, they will float right to the top. And the ones that have a really long carbon chain, they will sink to the bottom. And there will be all of these different outlets at different stages of the column where you can get the oil out at different qualities and different lengths of hydrocarbon. And basically the highest ones, those are the highest quality hydrocarbons, and they're the cleanest burning and the most expensive. And the ones at the real bottom, those are the really long hydrocarbon chains, and they're the real thick, viscous chains. So you can see here that when the hydrocarbon has only 1 to 4 carbon chains, so anything from methane, ethane, propane and butane, that's a gas and that comes out right at the top. Now, what do we use that for? We use that for LPG bottles, for the gas for your oven. And then below that you have chains of 5 to 9, so that's pentane to nonane, I believe. That's usually used for in the chemical industry for making cosmetics and moisturizers and things like that. From pentane to decane, that's usually used for petrol for your car. A slightly lower quality fuel would be decane to C16. I'm not sure what that is. Oh, kerosene. So that's usually used for aeroplane fuel and that sort of thing. And then you've got diesels, and then you've got lubricating oils. So yeah, lube that you would use on your car. And then below that you would have very thick fuels for only very large machines, such as steam, tanker ships, and maybe also the oil that is used in central heating. If any of you have ever lived in a cold country like the UK, they have central heating pipes that heat up this oil inside it, and the oil runs through the house, keeping the house nice and warm. But at the very bottom of that column, you've got the longest hydrocarbon chains. Now, these hydrocarbon chains have over 70 carbons in them, and it is really thick, and it is viscous, and it's bitumen. Bitumen is the lowest quality hydrocarbon that you get from the oil industry, and so it's very low cost. It's actually a waste product. Usually the oil industry will pay people to take the bitumen away, and this is used for road surfaces and for roofing and for waterproof paints. because like all oils, the real best property of bitumen is that it's waterproof. Now, it's usually you experience it as being liquid, but it's usually sort of at a semi-solid um, um, state at air temperature. It turns to liquid at around 40 to 50 degrees Celsius. Okay. Now it's very adhesive. That means it's very sticky. And it's one of the great things which separates it from tar is that it's very flexible. That means that if I had a big clump of bitumen, I could stretch it in my hand like Play-Doh. It's very flexible. But the real big one is it's abundant. It's everywhere. Everywhere they are refining oil now, because you're exporting crude oil, you can't refine oil for the entire world. Countries are buying crude oil from countries, refining it themselves, and they're being left with this waste product called bitumen. And that can be used on the roads mostly. So remember what we learnt about in the very first lecture with all materials. It depends on compatibility and availability. Tar is no longer available the way it once was. Bitumen is available. So there is one kind of bitumen that's called cutback bitumen. Now what's this kind of bitumen? Well, it's basically bitumen that has been mixed with kerosene. So why would we want to mix bitumen with kerosene? Remember, bitumen is the hydrocarbon that is at the very bottom of the fractional column. Kerosene comes out in the middle. It's the same stuff that a lot of people use in heaters here in Kurdistan in the winter. Why would we want to mix them together? Well, remember, bitumen is solid or semi-solid at room temperature. And even when it's liquid, even if you heat it up to it's still going to be very thick and pasty. It's going to be very viscous. So it's going to have a texture similar to Marmite, for those of you who've ever had Marmite. Okay, maybe not. What else? It's going to have a texture similar to a very thick yogurt or peanut butter, if you like. Now, that's a bit of a problem when you're making asphalt, because remember, bitumen needs to be mixed with aggregate in order to make asphalt. Why can't, if it's really viscous, it's going to have very low workability, similar to concrete. It's going to be very hard to mix it. And then because of that, the asphalt is going to be clumpy. There's going to be big parts full of aggregate, parts full of bitumen. It's not going to be properly mixed. We need a way to make the bitumen less viscous, to make it more runny. How do we do that? We add kerosene. And this kerosene, we call it a diluent because basically, in a way, it kind of dilutes the bitumen. 1 second. So, sorry about that. So, mixing the bitumen with the kerosene makes it runnier. It makes it more workable, if you like. You can then mix it with the aggregate, and you've got a good asphalt, which is very runny. It's got good workability. And then you can lay it out on your road surface to make an asphalt wearing course. So basically the road will be protected from the dangers of rain and wind, and also cars driving on it. It creates sort of a surface that protects the road. And then what's going to happen is the kerosene is going to evaporate. It's going to evaporate, and when it evaporates, it leaves behind the bitumen. So remember, kerosene has a much lower evaporation point than bitumen. So kerosene naturally wants to evaporate on any, I think the evaporation point of kerosene is at around 30 degrees Celsius, I believe. I could be wrong. And so once it evaporates, you're left with the bitumen, and the bitumen is hard or semi-hard. It's a semi-solid, so it creates a hard wearing course on your road with the asphalt, so it can't wear out. Now, as it's evaporating, what we call this evaporation of the diluent, we call that curing, not to be confused with the curing of concrete. But they do achieve the same thing, because basically the asphalt is going hard as the curing takes place, just like and getting stronger, just as the curing with concrete actually makes the concrete stronger. So there are different kinds of diluents we can use. As well as kerosene, we could use petrol. We could also use diesel. And they will cure at different rates. So diesel is very slow, gasoline or petrol is very fast, and kerosene is sort of in the middle. So how do we choose which kind of cutback, which kind of diluent we add to the bitumen? Well, basically it will depend on how fast a curing we want. If we need it to be very fast, because we need the road to harden quickly so that we can get cars on the road quickly, we're going to use a petrol diluent. If it doesn't matter so much, we'll probably use a diesel or a kerosene. Now the big issue, that usually kerosene, the big issue though is petrol is very expensive, and so is diesel. So unless we want fast curing, we're going to use kerosene as the diluent, and I think that's the one used 95% of the time with cutback bitumen. Now there is a little bit of a disadvantage with cutback bitumen, namely that as the kerosene evaporates, it's going to go into the atmosphere, and that's a greenhouse gas. That's actually a very strong greenhouse gas. One molecule of kerosene will actually have about 1,000 times the effect as one molecule of carbon dioxide. So it's going to create greenhouse gases, which is something that we're becoming more and more aware of as civil engineers, and we need to play our part to address. So that's a disadvantage with cutback bitumen. The other big disadvantage is actually expense, because gasoline in particular, it is quite expensive if you need fast curing. So this is a picture of cutback bitumen. This is a mixture of bitumen and kerosene. And basically it's in that tank, and the bitumen and the kerosene has been mixed together, and you can see that it then can be squirted out by a hose through a small pipeline. It's turned into a very runny and highly workable liquid. Now if we were just doing bitumen, we wouldn't be able to do that, because the bitumen on its own is like a big thick toothpaste at the best of times, where we're going to spend many months trying to roll out the bitumen over the road. It's just not feasible. Mixing it with the kerosene gives it that lower viscosity, which makes it runny and workable. Now you can also see there's a little bit of steam coming off it. Can you see that? Well, that's actually the beginnings of the kerosene evaporating. It's also a little bit of water, that's because hot water has probably been part of the mixture, but it's kerosene evaporating. going into the atmosphere. And what would happen is if you go back further on the road, you would notice that actually this black bitumen surface has dried because the kerosene has evaporated, and it will be much harder and stronger than what it is right here, where it's all wet and sticky. So remember, with cutback bitumen, you're trying to decide what to use as your diluent based on the speed of curing, basically how fast it will evaporate. Now, if you are basically creating a road pavement and the road is closed, potentially you can use a slow curing diluent, something like diesel or kerosene. However, if you were fixing a pothole, you would probably need a fast curing diluent like petroleum. Why is that? Well, with a pothole, the road is still open. Someone will come, fill in the pothole, compress the asphalt and drive off, and immediately people are going to be driving over that asphalt. And while the diluent is still in the bitumen, it's going to be very soft and spongy and weak. So you need it to be faster curing so that it'll go hard and strong faster. Now, it also depends on the aggregate grading. Just as the grading of aggregate had a big effect on the strength of concrete, it does influence the strength of asphalt as well. If it is poorly graded, well, you're going to have big voids that are going to be filled with bitumen. Can you see that in the bottom right-hand picture, those big voids? Now, those big sections of bitumen, they're going to need to go harder, faster, because they're going to be weak while the diluent is inside them. However, if the aggregate is well graded, like the picture on the bottom left, then the voids, the gaps that are filled with the bitumen, are going to be much smaller, and it's not going to matter so much if the diluent is slower to evaporate. So remember, rapid curing gives it strength faster, and if it's well graded, it's already got strength in the aggregate. So basically the curing doesn't matter too much. The speed of curing doesn't matter quite so much. But as I was telling you earlier, cutback bitumen, that is basically dying out, and it's more or less because of the environment and also just the big expense of mixing kerosene or petroleum through the bitumen. So how do we make bitumen more workable? How do we decrease the viscosity of bitumen so it's all runny and we can place it? Well, there's another kind of technique where we basically emulsify the bitumen. What do we mean by an emulsifier? Well, basically an emulsifier is basically soap or detergent. So think about this. Imagine you've got dirty hands because you've been working in the lab and you've got oil over your hands. Now you go to clean your hands under the tap and you put water on your hands. Are your hands going to get clean? No, they won't. The reason for that is because oil is water resistant. Now what you then do is you use soap or detergent and you work your hands into a lather and then you put your hands under the tap, and then all the oil breaks off your hands. What's happening? Well, the soap and or the detergent, that actually acts as an emulsifier. An emulsifier basically breaks down the oil, in this case the bitumen, into lots and lots of tiny microscopic bubbles, similar to that picture you see on the right. And these oil bubbles or bitumen bubbles basically float in the water that you're adding that comes with the emulsifier. suddenly it's a lot more workable. It has a much lower viscosity. That's what an emulsified bitumen is. It's basically bitumen that is split up into tiny, tiny microscopic bubbles that float in a pool of soapy water. And yeah, that emulsifier is about 15%. It's about 15% water and soap. So that's an emulsified bitumen. This is a picture of emulsified bitumen here. Now, the emulsified bitumen, the big disadvantage is, especially if you add too much emulsifier, you try to decrease the viscosity too much to make it workable, all of the oil is going to float to the surface. All of the bitumen will go to the surface, and at the bottom you're going to have the soapy water. Now, if you have a lot of rain, basically that's going to wash these bitumen bubbles away. If it's not properly emulsified, if it's basically got too much emulsifier in it. So when you're using emulsified bitumen, you always do it on a sunny day. You don't have a problem with that in Kurdistan. You've got plenty of sunny days, but you want to keep it reasonably dry. Otherwise, all of the oil is going to float to the surface. So this is a picture of emulsified bitumen, and so you can see here they're actually repairing an old car park, and they're spraying emulsified bitumen onto the car park. If you look at that tanker, inside that tank they've got a mixture of bitumen, and it's being mixed with soapy water or an emulsifier. And that's turning the bitumen, which is usually a very thick gunk, into a very runny and workable liquid. So much so that it can actually be sprayed out of a very small nozzle, and it's being used to spray this car park here. So that's emulsified bitumen. So viscosity is a very important property of bitumen. Now, just like the cutback bitumen, that soapy water, that's going to evaporate in time, and the bitumen is going to go to being solid or semi-solid. And so basically that car park, it's not going to remain wet and sticky. It's going to go hard and strong. Just leave it for a day or two. Right now, that man's boots are probably sticking to the bitumen. But leave it for a day or two, and it's going to go hard and strong. And it's going to create a nice waterproof barrier over the car park so that it can't be destroyed by rain or hail or snow or even lots of driving on the car park. It protects the car park. And so that's one of the great uses of emulsified bitumen, and we're using that more so these days than cutback bitumen. However, it does seem, because of the sheer ubiquity of petroleum products in Kurdistan, and because the government often gives kerosene for free, I do notice that a lot of places they're still using cutback bitumen for the roads and whatnot. Well, guys, that's all for today's lecture. It's a shortened lecture. These pages from the Civil Engineering Materials textbook, remember it's supplementary reading. You don't need to read it if you don't want to. But next week we're going to be looking at the properties of asphalt, and that'll be a slightly longer lecture. The properties of bitumen and the properties of asphalt. So we'll talk about that next week. And then we will also have a final review before going into the final exams. Okay guys, if you've got any questions, please let me know during the Zoom tutorial, or speak to me by a phone call or by email. God bless guys. Thank you very much.